Hi, my name is Guido Kremer and I'm working at the University Leipzig in the newly found Remote Sensing Center for Earth System Research. Welcome to my talk, The Low Dimensionality of Development, where I'm going to present some results we have done in collaboration with the MPI for Biogeochemistry in Jena, the University of Valencia and the Global Data Lab. How do we measure human development? One way to measure the human development, which is used by the United Nations, is an indicator called the Human Development Index, which integrates three dimensions: a long and healthy life, education, and a decent standard of living. The Human Development Index is an abstract indicator. An abstract indicator tries to measure something that cannot be measured directly, such as human development. Experts transform the relevant data streams so that the result resembles the abstract property they want to measure. The question is there a better way to create such indicators? One that is not expert but data-driven. Using dimensionality reduction, we can reduce the number of dimensions in a dataset while still maintaining important information. As a dataset, we use the World Development Indicators, which is a dataset curated by the World Bank, which contains yearly development data for every nation on the planet. From the database, we use 621 indicators from 180 countries. We found that we could compress the 621 variables from the World Development Indicators to only 5 components while still explaining over 90% of variance. On the figure to the right, you can see the embedding of our dataset in the first 2 dimensions of reduced space. Every point is a country at a certain year, and the trajectories of countries are connected by lines. If we take a closer look at the axes, we find that the first axis is a gradient of wealth, education, life expectancy, health, and the population pyramid. So it comes pretty close to the meaning of the Human Development Index, while explaining much more variance of our data set. The second dimension integrates a gradient over gender ratios on the labor market and the general population, as well as the electricity production and the fraction of 25 and 29-year-olds, which are the central part of the population pyramid. There are also interactive plots available online and a table where you can see the correlations between all the indicators and our final dimensions. On the figure to the right, you can see the trends of the first and second dimension over time. You see that large parts of the world are getting wealthier and societies are getting older. In the figure to the left, you can see the trends aggregated by geopolitical regions, and you can see that the same positive trends. You can also see that the trend in sub-Saharan Africa is markedly slower than in the rest of the world. We have shown that we can use dimensionality reduction as an effective framework to create development indicators. Dimensionality reduction can also give us measurements of how many dimensions we need, and we can also be sure that we get the dominant dimensions and that the dimensions are not redundant. So thank you for listening, and if this has piqued your interest, I will be waiting for you in the breakout room. See you later.